In this video, we will discuss how to apply the integration to find the area of a surface of revolution. We will apply the proper integral to solve this problem. We can use geometry analysis to determine the area of curved surface for any regular shape such as the cylinder here. So for example, in this case, let's open the curved surface. So the height here multiplied with the circumference, you get the area for the red surface. And you have two blue surfaces with pi r squared each. So take the summation of all the area. Then you can obtain the total area of the cylinder, which is equal to 2 pi r squared that is obtained from these two circles, and add it with the area from the curved surface. So how to compute the area of the curved surface is one of the main focus in this study. And you can see that for a regular shape like this, we can find the area of the curved surface by using the geometry analysis. For example, the area of the curved surface here is just the height multiplied with the circumference here. And before you open the cylinder, this circumference is the same length with the circumference of a circle. So the circumference for a circle with the radius r is equal to 2 pi r. So take the 2 pi r multiplied with h. This is the area of curved surface for a cylinder. In this example, it shows the geometry analysis to find the area of curved surface for a cone. You can see that this one is a cone, and you have the parameters length, height here, and the radius r here. So for this circle, the circumference is equal to 2 pi r. Let's open this cone. So once you open it, you should obtain this geometry. Therefore, the distance here is equal to the circumference, which is also equal to 2 pi r. And then the length here is still remain the slant height here. So now you can see that for this curved surface, you have some angle. And if you continue to plot a circle, then you should obtain this, where you can see that in this case, for this circle, the radius is equal to the L, which is equal to the slant height, and then you have angle with the circumference for the circle, 2 pi r. In simple, from the geometry analysis, we can find the area of the curved surface for a cone by using this formula, pi r multiplied with L. So if you have the radius, let's say in this case is equal to 5, and the slant height is given L is equal to 10, substitute inside this formula, then you should obtain 50 pi. So 50 pi is the area of the curved surface for the cone with this geometry. So the 50 pi is the area in this region. To understand how to obtain this formula, you can refer to the derivation here. We know that for a full circle, the angle here is 360 degrees or 2 pi radian. And the area of a circle is equal to pi r squared. Since the radius here is L, therefore the total area is pi L squared for a circle. So the curve length is the circumference for a circle is 2 pi radius, where in this case your radius is L. Therefore the total circumference for this circle is equal to 2 pi L here. For a sector of circle which is in this region, so this is due to the curved surface of a cone, and we don't know what is the angle for this sector of circle. And the area of this sector of circle is unknown. We only know that the curve length is equal to 2 pi r, which is from here up to this point. To find the angle of the sector of circle, which is here, we need to refer to the angle and the known information for the curve length here. So the angle here can be obtained by equal 2 pi r divided with the 2 pi l multiplied with 2 pi, which is this, and then 2 pi can be cancelled. You obtain 2 pi r divided by l. By performing this formula, then you can obtain the angle here. So you can continue the same approach to find the area by referring to these two information and the area here. So the area of the sector of circle here, or the curved surface of the cone. So to find this area, we can take the 2 pi r divided by 2 pi l and multiply it with the pi l square, which is this, and then 2 pi here can be cancelled, and you have the l cancel with l square, you obtain l only. Therefore, the total area here is equal to pi rl. So we have success to use the geometry analysis to find the angle and also the area for the curved surface of a cone. So far we used the geometry analysis to find the curved surface for regular shapes such as cylinder and cone. However, in some cases, it's difficult to obtain the curved surface like this, and it sometimes is not applicable to find the curved surface using the geometry analysis. For irregular shape items like this, geometry analysis is not much useful to solve the problem. However, we can use the integration technique to find the curved surface of this irregular shape item. So we will learn this, and this is the main focus in this study. In this example, we will use the integration technique to find the area of curved surface. So in this case, let us have a function y equal to fx function, and then if you rotate this function by 360 degrees in the x-axis, then you should be able to obtain the cylinder shape. Previously, you have learned that we can use this formula to find the arc length. For example, in this case, we can use it to find the distance from here to here. So in this case, it's a straight line. However, this formula can be applied for any curved line. This formula can be extended to find the curved surface, where you can see this part is similar with additional 2 pi fx here. For the later part here, we know that it's computing the arc length. For example, in this case, that the 2 points in this function should be very small, where the delta x approaching 0. So in this case, if you perform this formula, then you can find the distance between these 2 points. And if you take the integration from a here to b, basically you are taking the summation of all the distance from a to b. Therefore, this can give you the arc length. Fx here is the height of the function, where you can see that at this particular x here, so this is your fx, which represents the height. So if you multiply it with 2 pi, basically you are computing the circumference. In simple, we can treat the fx to be the radius when we are rotating the function fx with respect to the x-axis like this. So 2 pi fx here give you the circumference. On the other hand, when you multiply with the arc length, then you should be able to obtain the curved surface within this region. Like this, where this is the front surface and this is the back surface of the cylinder. So if you continue to integrate from a to b, it means that you are taking the summation of all the curved surface from A to B here, then you should be able to obtain the total curved surface for the cylinder by using this formula. Make sure you master this. When you integrate this formula, it gives you the arc length. When you integrate the arc length formula, which is multiplied with the 2 pi fx, which is the circumference when you rotate the function fx with respect to the x-axis, where the fx function here is the radius. So 2 pi fx gives you the circumference here. So integrate the circumference multiplied with the arc length function here, give you the area of the curved surface. In this example, you have a function fx equal to 5 here with the limit 1 to 8. So the length here is equal to 8 minus 1, which is 7. Fx equal to 5 is the height of this function, which is also the radius. So when you take the 2 pi multiplied with the radius here, give you the circumference. 2 pi radius, where the radius is equal to 5, give you 10 pi. So take the curved length here, multiply with your height, you obtain the area of curved surface for this cylinder. So the final answer is 70 pi. So this will be our benchmark. Let's try to solve the same problem, but in this case we are using the integration technique. For this method, you need to imagine if you take the fx function here and rotate it in the x-axis like this, then you can form a cylinder based on this revolution. The area of the curved surface is given by this integration formula, where 2 pi fx here is the circumference, where the fx is the radius, which is equal to 5. This part here gives you the arc length, so you need the dy over dx for this formula. Since the y function here is equal to a constant 5, dy over dx, differentiate the constant, give you 0. So you can substitute it inside, and the radius here, the fx function, is equal to 5. Lower and upper limit 1 and 8. So you can start the integration. Integrate the function here, which is a constant, give you 10 pi x, and then you substitute the upper and lower limit, minus it, and you should obtain 70 pi. So when you compare this with the previous result that you obtained from the geometry analysis, you find that both methods give you the same answer. Therefore, it is verified that we can use this formula to compute the area of curved surface. In this example, you have a cone and you are going to find the curved surface like this. So we can find this by using the geometry analysis, which is given by this formula. And you need the radius and the slant height. So the parameter is given here, where you can see the radius here is equal to the function here when you substitute the b equal to 6. So when you substitute 6 inside this function, then you should obtain the radius equal to 10. So here you can write it, your radius is 10 here. 6 minus 1 gives you 5. So here is your slant height. Therefore, you can find the height here by consider this triangle. So you can take the 5 square plus 10 square and take the square root. Then you should be able to obtain square root 125. Substitute these two information inside. Then you get the final answer for the area of curved surface for this code. Let's use the integration technique to solve the same problem. If you have a function fx equal to 2x minus 2 with the limit 1 to 6, so if you revolve the fx function here with respect to the x-axis, then you can see that you will form a cone like this. So we can continue to use this formula to find the area of the curved surface. So you have the limit 1 to 6, which is substituted inside the a and b here. So the function fx here is the radius of the circumference. So we substitute the fx equal to 2x minus 2 inside, and we differentiate this. So this is your y. So after you differentiate, you obtain 2. So the dy over dx is equal to 2. Solve the integration here. This is square root of 5, which is this. Integrate the 2x, give you x squared. Integrate constant negative 2 here, you obtain negative 2x. Substitute the limit inside and take the subtraction, then you should obtain the final answer. So when you compare this to the previous geometry analysis result, both are the same. Therefore, again, you verify that we can use the integration method to find the area of curved surface. There is an alternative to solve this problem. We know the arc length is without the 2 pi fx function here. And this arc length can be equal to this formula, where you change the limit to CD, which is in the y-axis. So if you compute either this or this formula, you should obtain the same arc length value here. This gives you the flexibility when you have some dy over dx function that is difficult to be integrated, then you can convert it to the dx over dy here, which might be more easier to solve. When we multiply the arc length with the circumference, then you obtain the area of curved surface. In alternative, you can also obtain this formula by multiplying it with 2 pi y, where the 2 pi y here is still the same circumference, and y is your radius, and y is equal to the fx function. So in this case, your CD will be changed to 0, because your C lower limit in the y-axis is equal to 0 here, and the upper limit is here. When the x is 6, substitute inside this formula, you obtain your y is 10. So this is your upper limit D. To find the dx over dy, you need to know what is your y. Since your y is equal to 2x minus 2, from here you obtain x is equal to y plus 2 divided by 2. So you obtain y over 2 plus 1. And then differentiate x with respect to y, you should obtain 1 over 2 only. Therefore, you can substitute this inside. You should be able to obtain the same answer after you solve this integration. Previously, you have the function fx equal to 2x minus 2 here. So if you rotate with respect to the y-axis instead of the x-axis, so you rotate it 360 degrees. In this case, you obtain the conical frustum. Although we have a more complicated shape here, we still manage to compute it by using geometry analysis, and you should be able to obtain the area of the curved surface. If you open it, you should be able to obtain this, and this curved surface area is equal to 2 pi r multiplied with L, where the R here is the radius 1 here for the small circle here, and then plus the radius 2 for the big circle here, and divide it by 2. So in this case, the radius 1 is equal to 1 here, and the radius 2 can be obtained from here, which is equal to 6. Then you can substitute inside this formula to obtain the average radius. The next parameter that you need is the slant height, which is located over here. So this is your slant height. Let's form the triangle here. Here you have 5, here you have 10. Therefore, this L is equal to square root of 5 squared plus 10 squared, which is this. Substitute it inside the formula. Then you can obtain the area of curved surface to be this answer. Let's try to solve the same problem by using the integration technique. So in this case, instead of revolve the fx function here with respect to the x-axis, we revolve this function with respect to y-axis here. In 3D, this will be your y-axis, and this is your fx function. So if you revolve the fx function 360 degrees with respect to the y-axis here, then you will get 3D shape like this. So if you want to know what is the area of curved surface here, then you can use this formula, or in alternative you can use another formula to compute it. You should be able to recognize and know that this term is the arc length. One is integrate with respect to dy and another is integrate with respect to dx. Without this, these two arc length formula are computing the same thing. Previously, when you multiply this arc length with the circumference 2 pi fx, where your circumference is here, fx is the radius, where your y is equal to fx. Then in this case, you know that this function is rotate with respect to the x-axis. However, in this case, we are rotate with respect to the y-axis. So you need to change the radius of the circumference into the y function. So what is y function? Basically, x is equal to your y function. So you can see that when you rotate to the y-axis here, so this is your radius and this radius is your x, equal to fy function. Therefore, we can find the area of curved surface by using this formula. And when you substitute x equal to fy, you obtain another formula. In simple, if a function is given, let's say this function is equal to this, 2x minus 2, which is also equal to y. So from here you can find the x, which is equal to the y plus 2 divided by 2. So this is in the y function. If you rotate it with respect to the x-axis, then you need to consider the circumference here, where the radius here is equal to y equal to fx. So if you use this radius of circumference to compute the area of curved surface here, for example in this case, if you integrate with respect to y, then here must be in the y. So instead of using the fy function, you are using the y only. So in this case, you are actually computing this area of curved surface for this cone instead of these two geometries. On the other hand, if you rotate it with respect to the y-axis here, then this will be your radius. Is equal to the x of fy function here. So if you substitute the radius to be fy or the x, then you actually compute the area of curved surface for this geometry. Let's continue to determine the area of the curved surface here by using this formula. So you need to integrate with respect to the y-axis, so the limit must be in the y-axis here, which is the c and d. Is given 0 to 10 here, so you can substitute. And then the fy function has been found to be this, so you can substitute inside. And then the dy over dx, you can further differentiate it. So y over 2, after you differentiate, you should obtain 1 over 2. 2 over 2 is 1, after you differentiate, you obtain 0. Therefore, this is the answer. You can substitute. So you can continue to do the integration, then you should obtain this answer. You actually obtain the same answer with the previous geometry analysis result. Again and again, we verify the accuracy of this formula. Therefore, you should have confidence this can determine the area of curved surface in high accuracy. So in alternative, you can also try with this formula, is to give you the same answer. Let's try with more example. In this case, the function is given here, where you see this line, and then you are going to revolve it in the x-axis. Therefore, after you revolve, so imagine that at one point you revolve it by 360 degrees, and then you continue to do that for all the points located at the function. Then you should be able to obtain this shape. To know the area of the curved surface, you need to integrate, and inside you have the circumference and also the arc length. In this case, let's say you have the circumference here. So this is the radius. The radius is equal to y or fx function. Depending on which direction you want to integrate with, let's say if you integrate with respect to the x-axis, then you need to put the fx function inside. If you integrate with respect to the y-axis, then you need to put the y inside. And also you need to choose the correct arc length formula for both cases. Make sure you know how to formulate this formula. Let's continue with this. So you can substitute the a and b inside, which is equal to -1 and 1. And then you can substitute the fx function. So the fx function here is equal to y. So you can substitute this inside. And then differentiate it with respect to x-axis. So this one is in the power of 1/2. After you differentiate, you need to multiply 1/2 there, and then the power will need to minus with 1, become -1/2. Therefore, you obtain 1 divided by square root 4 minus x squared term here. Then lastly, you need to differentiate 4 minus x squared. Differentiate 4 give you 0. Differentiate -x squared give you -2x, which is this term. So you can continue the integration, and lastly you should be able to obtain this result. In alternative, you can also try with this formula to see if you can obtain the same result.